Okay, so since we are talking about nature-based solutions and we looked at opposition from a few groups to this concept of nature-based solutions being used by corporations, food, energy companies, and IT companies, and so on. I thought I'll add this under coming attractions because large number of corporations have signed on to net zero goals and everybody wants to be seen as environmentally friendly. Apple puts out its own documents on how well they have planned net zero. I've included Apple's information in the other course called How Bad Are Bananas, where we look at carbon footprints of various things. So here I'm going to use an article actually written by Microsoft staff. Microsoft has committed to net zero as well, and we'll go through some of the details of what they're trying to do. And this team actually highlights some of the issues on trying to meet net zero goals that they want to achieve. So obviously they are investing some money, but they're also looking at financial incentives to actually do it. Okay, so it depends on who you ask. Some people are automatically against corporations, but I think we're all in this together, and our lives completely depend on corporations. There is no doubt at all. Plus, my retirement fund may be invested in various corporations that I don't even know about. Okay, so we write. The authors say we write as a team composed of Microsoft staff working on the company's carbon negative program and research scientists who analyze carbon reduction and removal strategies. So it's a combination of scientists and staff. We highlight 3 bugs in the current system: inconsistent definitions of net zero. I'll show another graphic for this. Poor measurement and accounting of carbon, and an immature market in CO2 removal and offsets. Okay, so it's a market-based strategy. These challenges need to be overcome if the world is to reach net zero by mid-century. Okay, legitimate points. They conclude at the end, companies need better economic incentives to promote the most effective forms of CO2 removal. So CO2 removal, you can do it as based on how long the removed CO2 is going to remain out of the system, or you can see how cheap it is, even if it is going to be re-released in a few years, because you can always say, okay, we removed what we emitted and we are done. But if it's released after 20 years, then obviously you are not done. Plus, you have to also make sure that the methods you are using are actually overall good for the environment. Equity, all kinds of other issues can be raised as well. Going into details, in January this year, this is in 2021, Microsoft made a major announcement. It had paid for the removal of 1.3 million tons of CO2 from the atmosphere. Not a lot, but still. Among its purchases were projects to expand forests in Peru, Nicaragua, and the United States, as well as initiatives to regenerate soils across US farms. So here we are into nature-based solutions already, which was the issue raised in the previous podcast. Microsoft will pay the Swiss firm Climeworks, which is doing a lot of so-called direct air capture. Air flowing through the system is used to remove remove CO2, and Iceland installed the biggest one in the world, but that only removes about 870 cars off the road. That's how much carbon it removes. So scaling up these methods is still a big challenge, as we will see. So Microsoft will pay the Swiss firm Climeworks to operate a machine in Iceland that pulls CO2 from the air and injects it into the ground, where it mineralizes and turns into stone. So long-term storage. The amount of CO2 to be removed is equivalent to about 11% of the annual emissions from the Microsoft's value chain. So it's not a very big percentage. These are offset methods, right? So you are not necessarily reducing emissions unless you are very carefully planning those activities as well. If you keep emitting and saying somebody is going to offset, then at best you are reducing the rate of growth of CO2. You are not reducing CO2 in the atmosphere. Okay. Of this, the company will count less than half as being certified to officially compensate for its emissions. It is the largest corporate procurement of carbon removal so far. Patting themselves on the back. So we have talked about this in several courses and several occasions about using planting forests and improving their management as nature-based solutions that companies can use to remove and store carbon. And this is argued to be dishonest, depriving people of livelihoods, indigenous people, and making land inaccessible to the people who depend on them, and so on and so forth, from the groups that are opposing nature-based solutions, especially for corporations. But they also blame the conservation groups as taking money from corporations and participating in this dishonest practice, as they say it. Okay, the aim is that by 2030 the company will be carbon negative. By 2050 it will have removed all of its emissions since it was founded in 1975. So it's not only going carbon negative, but it also wants to remove past emissions, which is great. Indeed, there is no standard way to measure, report, and verify carbon removed. Such ambiguity is a barrier to investment. So already they are saying we want to invest, but we don't know whether this is really well incentivized and whether we'll get the credit for doing what we are doing. So that's corporate jargon again to hedging bets, right? You say we want to do this. How do we do this? Tell us. If there is no way to know, then we are not going to invest. So it protects them in some ways. It is cheaper and easier to establish trees and enrich soils than to deploy nascent technologies that capture carbon and store it geologically. Biosphere-based storage projects cost only $16 per ton of CO2, whereas geosphere-based storage costs on average $141 per ton of CO2. The range is $20 to $10,000 per ton of CO2, depending on which method you are using. So obviously there is a lot of activity on trying to do geoengineering of removing carbon capture. So removing carbon using the so-called carbon capture, utilization, and sequestration methods. Some carbon removal strategies, nature-based methods for storing carbon dioxide, are relatively cheap and currently available, but carbon stored in terrestrial ecosystem is at risk of release by fires and pests. For example, we have seen many fires across the globe, Australia, Spain, US, that are basically re-releasing the carbon stocked in forests very quickly. Geological storage could be permanent, but today's technologies are pricey and immature. They don't scale up, right? There are some potential side effects being seen here as well: positive, negative, and none. Evidence: low confidence and medium confidence. So biosphere storage in plants and soils, managing forests and soil sequestration. Impacts on water quality: positive. Soil sequestration, positive. Water quantity can be positive or negative depending on how much the forest takes up. But soil sequestration is positive. Food supply can be affected negatively by growing forests. The claim, as we saw in the previous podcast, is to say we'll grow forests on degraded land, but this is not very well monitored. But soil sequestration can still benefit. Biodiversity also can be positively or negatively affected. Sequestration per year potential of more than 3 gigaton CO2. 0.3 to 3 gigaton CO2 in soil sequestration. Measurement and verification is fair for managing forests but poor for soil sequestration. So here impact ratings are from the Intergovernmental IPCC, sixth assessment report, apart from measurement and verification, which are based on author's judgment. So here also BECCS, bioenergy with carbon capture and storage, gigaton CO2 and gigaton of CO2. Those are from BECCS here, okay? Let's see, the star is from somewhere else, so I have to be careful. Okay. What about the geosphere? Storage in rocks and minerals. BECCS, okay, here we are. Bioenergy with carbon capture and sequestration. Water quality impact negative, air capture negative, water quality negative, water quantity negative, air capture. So air capture will have negative impact on water quality. Will have positive and negative impacts on water quantity. Food supply will be potentially negatively affected by BECCS because you're competing for land for bioenergy crops versus food security crops, food crops, and there is often competition of food grains when they are being used for bioenergy, like ethanol. Additives have had examples during drought where they raised corn prices and so on. Okay, so one has to be careful. No effect from air capture. Potential again greater than 3 gigaton CO2 in both cases, BECCS and air capture, and the measurement and verifications are fair for BECCS and good for air capture, which is monitors it well. So nature-based removal is constrained by area and competing uses of land. That's reference 6 in the paper. Engineering solutions can scale up but are currently scarce, expensive, and resource intensive. So one has to be careful that something that is removing carbon is actually not using more carbon to remove some carbon. Estimating whatever carbon it removes. Estimating emissions from supply and value chains is more difficult. It requires calculations from all suppliers and users of companies' products and services. So Microsoft, like Apple, is trying to address the issue of reducing emissions and not just offsetting emissions. So it is looking at its suppliers and transportation and companies' flights, meetings, energy use, water use, etc. 3/4 of Microsoft's emissions come from these, including building materials, business travel, product life cycles, and electricity that customers use. Okay, so carbon market snapshots. Again, in 2020, Microsoft and financial services firm Stripe received 189 and 47 proposals each from companies, respectively, for locking away carbon dioxide. Of these, 95% used nature-based storage, which is less durable than geosphere-based. Few options were available for permanent removal. Only 2 million tons worth was judged reliable enough to purchase, of around 170 million tons offered. So here are proposed volumes of storage with various proposals based on biosphere or geosphere. So here is geosphere and here is a mix of them. So forest, soil, ocean, and other geophysical, so direct air capture, BECCS, and mineralization, scavenging from the air. Okay, so estimated storage are here. Forest protection that lacked management to enhance the carbon sink was rejected because it leads to avoided emissions without additional carbon removal. So it's always about additional removal because there is a background level of CO2 in the atmosphere. You are putting additional amounts in, so you have to remove additional amounts out. Carbon negative doesn't necessarily mean you are immediately reducing total CO2. You could be removing someone else's CO2 by yourself being carbon negative. Gets complicated, but some of the details. So this is a paper that points out why there are inconsistencies in net zero targets. So it's all in the detail. Choosing different gases, different timing for net zero emissions, and different methods of aggregating emissions can have very different outcomes. So here are global greenhouse gas emissions, illustrative pathway for reaching net zero carbon dioxide and net zero greenhouse gas emissions. They are not exactly the same, right? We've been looking at CO2 equivalent, for example, as opposed to just CO2. So we are looking at CO2 here in this dark orange color. Yellowish color is non-CO2, so that is methane, N2O, and other fluorinated gases in global warming potential over 100 years. So you're looking at global equivalent emissions in gigaton CO2 equivalent per year. And this is time going from 2010 to 2100. and how much CO2 and greenhouse gases have to be removed. Reaching a net zero CO2 target, residual CO2 emissions are balanced by an equal amount of CO2 removal. So it's not net negative yet. CO2 removal has to start here. Already we are late actually. Reaching a net zero greenhouse gas target, residual CO2 and other greenhouse gas emissions are balanced by an equivalent amount of CO2 removal. So then you are adding this extra amount. Here you are only removing CO2 that is being put in, whereas here you have to remove additional non-CO2 greenhouse gases as well. So that's not as easy as removing CO2 necessarily. So what are the global warming implications of this? Estimated global temperature peaks in pink and declines arrows under net zero greenhouse gas emissions. So going again from 2010 to 2100, at some point we have to bend the curve. So net zero CO2 target global warming roughly stabilizes by about in the 2050s and 60s. Net zero greenhouse gas target will give us that in the 2060s and 2070s. Okay, so global warming peaks and then declines. Continued decline accelerated by global net zero net negative greenhouse gas emissions. So these details matter. What are the constraints on soil sequestration and biospheric sequestration? This is an abstract from this paper here, which cautions against overemphasizing the potential for soil sequestration of carbon. I'm a big fan of soil sequestration of carbon, so I have to be careful as well. Improved soil management is increasingly pursued to ensure food security for the world's rising global population, with the ancillary benefit of storing carbon in soils to lower the threat of climate change. While all increments to soil organic matter are laudable, we suggest caution in ascribing large potential climate change mitigation to enhanced soil management. We find that the most promising techniques, including applications of biochar and enhanced silicate weathering, where you crunch up rocks like olivine and spread them on soils, and because they are crunched, the acceleration, the weathering rates are accelerated, which draws down CO2. Obviously, there are lots of issues there as well. Together, they are not likely to balance more than 5% of the annual emissions of CO2 from fossil fuel combustion. So we have to be realistic about what is being used as nature-based conservations and what estimates are used in the sequestration potential for the future. Finally, the key points from this paper on the constraints over biospheric sequestration. I will go through these. This podcast is longer than usual, but that's okay. Land management interventions can contribute to climate change mitigation through avoided emissions from deforestation and forest degradation, and through negative emissions from increasing carbon dioxide removal via reforestation, soil carbon sequestration, and more. So here we are again with soil carbon sequestration. The largest existing estimates of negative emissions potential from nature-based climate solutions implicitly rely on a potentially risky strategy of increasing carbon storage beyond historical bounds. So there is the cautionary note. More conservative estimates that focus on refilling past carbon losses from the terrestrial biosphere are likely to be more feasible and have more co-benefits: air quality, water quality, soil carbon, crop yields, etc. Successful implementation of nature-based climate solutions requires rapid increases in financing, increased on-the-ground capacity, and robust policy and governance mechanisms. In the absence of broader climate action, climate change impacts on the biosphere will limit the potential for nature-based climate solutions to contribute to negative emissions. Warming, drying, distribution of rains, extremes are obviously increasing wildfires, which is a little bit complicated in terms of duration, intensity, and extent of fires, including human management that modulates the fire response to climate change. And there are vegetation impacts, soil respiration increases, pests increase, and so on and so forth. So all these things matter, and the cautionary note about nature-based solutions or nature-based dispositions provide a good context for these corporations adopting net zero plans based on these uncertain nature-based solutions of biospheric sequestration and soil carbon sequestration. Okay, just keep that in mind.